Welcome to Bite-Size Data Science. In the last two videos, videos 41 and 42, we talked about OpenCV and its capabilities for object detection and for foreground extraction. I just can't get enough of this library. This time we'll look at another capability related to edge detection, also referred to as contour detection. What we want to do here is to go from this image to this other one. We'll talk about how to do it, and then I'll ask for your help. Let's get into a notebook. I am using the IBM Watson Studio environment to run my notebook. If you are interested, you can find a link in the description on how to create a free account on that platform. Links to the notebook I'm using here are also available in the description. The process we're following is to take the original image and extract the foreground image. Then we do the contour detection. Let's see how it's done. We first install the OpenCV library and load our target image. As we can see, we're starting with an image that needs to be processed before we can do the edge detection processing. To do this, we get the YOLO 3 model. If you're wondering, YOLO stands for You Only Look Once. We apply the model on our image and use it to identify the object in the image. We find that we have only one object of type person. We can see here that the person is found in a specific area of the image, as shown by the red box. Using the bounding box to eliminate everything outside of it, we use the grab-cut method to extract the person from the image, as we can see here. We are now ready to do edge detection. The edge detection is done by simply applying the Canny method to our latest image. We get the following results. Here's the thing about this result. The input is a JPEG image. This is represented by a three-dimensional array representing the image height and width, and the three layers representing the RGB encoding. The result of the Canny method converts the image into a two-dimensional array. As we can see the edge in yellow and the background in purple. I'd love to say that it is exactly what I was going for, but it isn't. To me, the ideal result would be the edges in white and the background black. I spent quite a bit of time trying to convert the resulting edge image to that black and white result without success. The last theory I had is that the result is a color image in 8-bit encoding, meaning that each byte of the image represents one of a possible 255 colors. I may have missed something obvious, so this is where I want your help. If anyone can figure out how to get the black and white result I wanted and get back to me, I would greatly appreciate. Then I can pose the correct way to get the desired result. Anyone up for this challenge? See you next time on Bite-Size Data Science, and don't forget to subscribe.